Hi, today in this video we'll be talking about fitting of Poisson distribution. So what happens is sometimes we are given a frequency distribution and then we are asked to fit this distribution into a Poisson distribution. So in that case we need to learn the process of fitting of Poisson distribution. Even from exams point of view it is really important topic. So now what happens is first of all we simply know that for any Poisson distribution our mean is lambda, right? So mean is equal to lambda for any Poisson distribution. This lambda represents the mean of this distribution. So now what happens is let's suppose given a frequency distribution that is x and f. Let's suppose the data represents x1, x2, x3 till xn and the frequencies are as follows as f1, f2, f3 and so on till fn. Now let's suppose we are given this Poisson distribution, this frequency distribution, and now we are asked to fit into a Poisson distribution. So what we'll simply do is we'll simply find a mean for this distribution, right? Whenever we find the average or the mean for this distribution, we can simply equate it with this mean, right? So basically, obviously, whether it's a frequency distribution or a Poisson distribution, mean will always be equal for both the distributions, right? So we'll find a mean from this distribution and then equate it with the lambda, that is the mean of the Poisson distribution, right? And then we know that once the lambda is obtained, once we have this value of lambda, we can easily compute the probabilities for the distribution, right? So how? Now we know for any Poisson distribution, probability PR, or we can also write it as probability of x is equal to r, is simply equal to e to power minus lambda, lambda to the power r upon r factorial, right? So probability of x is equal to 0. Let's suppose p of 0 over here will become probability of x is equal to 0 is equal to e to power minus lambda, lambda to the power 0 just upon 0 factorial. That's it. So it's very easy. So by this we can simply compute the probabilities, right? But now, next is once you have computed the probabilities, probability of x is equal to r. Now the question is, are probabilities and frequencies same? No. Probabilities and frequencies are not same. So we need to compute that frequency because whenever we are fitting a distribution, we need to have a variable x and its respective frequencies. So for this, whenever we want to compute the frequencies, first of all, let's suppose n is the total observed frequencies. When I am saying total observed frequencies, I mean this is simply this. Sum of this frequency, summation f is equal to n. Right? So this n is simply summation f. So let's suppose the total observed frequencies is n. So when we are given then the expected frequencies of the Poisson distribution or f of r is simply given as n multiplied by probability of r or n into e to power minus lambda, lambda to the power r upon r factorial, right? Where this r can be equal to 0, 1 and so on. So is this clear? So basically what happens is when we have the probability and we have the total, then we can easily find out these frequencies, right? That is, okay, let's suppose we are given the probability is 10% or 0.1. So in that case we know, okay, that the 10% of the data or 0.1 into n is our required frequency. So this is the formula that we've used here. So now from this, now what we can say is, okay, particularly if we want to compute, let's suppose f of 0. So this becomes n into e to power minus lambda. Lambda we already know. This n also we can find from this distribution. Then lambda to the power 0 upon 0 factorial, which is simply n into e to power minus lambda. Similarly, f of 1 is equal to n into e to power minus lambda, lambda to the power 1 upon 1 factorial, right? So this is again equal to n into e to power minus lambda into lambda, right? Or you can also write it as this is this is lambda, right, into f of 0. But this is something that we really not require much. So basically like this we can easily compute all our frequency distribution, or we can easily fit our Poisson distribution, right? So now let's take an example. So let's suppose 100 car radios are inspected as they come off the production line and number of defects per set is recorded below. So we are saying that there are 100 car radios and we are inspecting them, and we are counting basically what are the number of defects in those particular car radios, right? Fit a Poisson distribution to above data and calculate the frequencies 0, 1, 2, 3, 4 defects, right? So we are given a distribution over here and we are asked to fit a Poisson distribution. So now we are given number of defects, that is in 79 sets there are 0 defects. In 18 sets there is exactly 1 defect, or there are exactly 2 defects in 2 sets, exactly 3 defects in 1 set, or exactly 4 defects in 0 set, right? So there is no set or radio set which has exactly 4 defects, right? So now when we will sum this up, so this is clear, when we will sum this up we will get it as 100. Why? Because there are 100 car radios, so this becomes our n. Now we know that in order to fit a Poisson distribution, first of all what do we need? We need mean, right? And how do we actually compute mean? In order to compute mean, we know that mean is equal to summation fx upon summation f. So first of all we know the value of summation f, that is n, that is 100. Now we need to find summation fx. For that we need a column f into x, right? F into x, that is this multiplied by this. So this becomes 0, 1 into 18, 18, 2 into 2, 4, 3 into 1, 3, and 4 into 0 is 0. Then we need a summation fx, so we need to sum this up. When we will sum this up, we will get this as summation fx is equal to 25, right? So we will put over here 25. So from here we can say that our mean is equal to 0.25. Now we know one thing, that our next step is to equate mean with lambda, right? So the mean of the given distribution mean is equal to lambda, that is mean of Poisson distribution. From here what we can say is that our lambda is equal to 0.25. So when we have computed that this lambda is equal to 0.25, half of the work is done. Now from here we know that f of r is equal to n into probability of r, that is n into e to the power minus lambda to the power r upon r factorial, right? So let's just write down over here f of r is equal to n into pr, which is equal to n into e to the power minus lambda to the power r upon r factorial, where r is equal to 0, 1, 2 and so on. Now we have these values. Now we need to calculate, we have already found this, calculate the frequencies of 0, 1, 2, 3, 4, right? So now when we want to compute this, what we will do? We will simply substitute the value of r is equal to 0, r is equal to 1, r is equal to 2, r is equal to 3 and r is equal to 4 in this particular formula. So what is this? This is n. N is 100 into e to the power minus lambda is what? Minus lambda means minus 0.25, minus 0.25. Then lambda to the power r means 0.25 to the power r upon r factorial, right? So this is simply this that we need to find. So now let's find these values. So let's simply copy down the formula that we have written. F of r is equal to 100 into e to the power minus 0.25 into 0.25 to the power r upon r factorial, right? So this is what I've computed. First of all, we need is f of 0. So f of 0 means 100 into e to power minus 0.25 into 0.25 to the power 0 upon 0 factorial, right? Or what we can also simply do is, we can simply take this value, we can also write this particular thing as e to power minus 0.25. This portion is common for all. So what is the value of 100 into 0 e to power minus 0.25 is simply 100 into 0.7788, right? 0.7788 is the value of e to the power minus 0.25 that I have calculated from, that I have checked from the e table, right? From here we can write this into 0.25 to the power r upon r factorial. So this formula can also be written like this, or we can also write this as simply as 77.88 into 0.25 to the power r upon r factorial. So we can write like this also. So first of all, f of 0 means simply 100 into, or we can simply substitute the value over here, right? 100 into e to power minus 0.25. This is equal to 77.88, right? Next is f of 1. So from here, let's use this now. So f of 1 simply says 77.88 into 0.25 to the power 1 upon 1 factorial, right? So when we are saying this is simply 77.88 into 0.25. This becomes 19.47. Please see, we'll start approximating these because these are frequencies. So when it's frequency, this becomes 19 and this becomes 78. Next is f of 2. F of 2 becomes 77.88 from here. I'm using this into 0.25 square upon 2 factorial. So this becomes simply, or we can simply say this as 77.88, this 19.47 into 0.25. So it does not matter how we are actually doing it, right? So when we'll compute this will simply come equal to 2.43. Approximately this is equal to 2. Next is f of 3. This becomes 77.88 into 0.25 cube upon 3 factorial. This will be equal to 0.20. So approximating it as 0. Then we have is f of 4. So f of 4 is simply 77.88 into 0.25 to the power 4 upon 4 factorial. And this value will turn out to be 0.0125. So this again is approximated to 0. Right? I am writing down these values directly because I already calculated them with me. Otherwise, it would have taken a lot of time. So I've just simply calculated it earlier with me and I've just written it over here. So now when we see this is 78, this is 79 and 79 and 100, sorry 80, and this is 19. But why is this? Now you must be thinking that the sum is not 100 over here. This is simply due to the reason, see, these were 0.2. This is 0.0125. This was 2.43. This was 19.47. This is 77.88. So we have simply approximated these, right? We have given these as approximated values because these are frequencies, right? So the sum cannot turn out to be exactly 100. There can be a gap discrepancy of 1 or 2. So that does not matter, right? So I hope you like this video. Do subscribe this channel for more videos. Thank you.